Section 8.3 of Chapter 8 deals with studying solutions of quadratic equations. So we might consider this section as sort of sitting on quadratic equations and then kind of thinking about it and trying various things. All right, some of the words we're going to be using: conjugates, and I think you're familiar with that. The discriminant is maybe a new term for you. We'll go over that. Irrational, you should know that. And rational. So let's put these words into our matching. As we look at this, we want to remind ourselves of the quadratic formula up here. And notice that under the radical sign, there is something that I have in blue, and that is right here. This is what I have in blue. This is called the discriminant. Now, when we are working the quadratic formula and our discriminant is 0, or our discriminant is, let's say, 5, or our discriminant is -6, in all of these cases, what our discriminant is determines the number of solutions we're going to have for this particular quadratic equation. If it's 0, as is indicated here, there's only going to be one rational number solution. If it is irrational under there, we're going to have 2 irrational number solutions. And if this is negative under there, we're going to have what we call complex conjugates down here. And let me give you an example of that. Again, if under the radical sign it is a negative number, the discriminant then determines that for our answers here, you're going to get 2 answers. Again, this is a plus, this is a minus, the same terms. These are called complex conjugates as answers. Now, for these, as we look at the part of the quadratic formula that we call the discriminant, which is this is in standard form. We're going to put our b, -3 squared, minus 4 is in the formula, times a, which is 1, times c, which is 10. So this goes 9 minus 40 equals a -31. So keep in mind, this is under the radical. So what type of answers are you going to get? Well, you're going to get complex conjugates. And how many will you get? Well, because this is plus or minus, you're going to get 2 complex conjugates. Little shorthand. Now here, our discriminant, there is no b, so it's b squared, which is 0 squared, which is 0. And this is going to be a -4 times 12, which will be a 48. So you're going to get two real solutions, and they're going to be irrational since that's not a perfect square. So two real solutions, irrational. Again, there is no b here, so b is 0. Minus 4 times a minus 15 equals a positive 60. So this is the same. Two real, irrational. So in number 8, our b term is a negative 5 that we're going to square, minus 4 times 6, which is our a term, and our c term is 0. So when we have a string of factors including 0, this becomes a 0. So we just have as our answer the square root of 25. So that's a perfect square. So here we're going to get two real solutions, but they're going to be rational. And those are the first 4 examples. And again, you have to be careful. Here c is a positive 15, and I put it as a negative 15. So this is going to be negative, and these are going to give us then not real, but two complex conjugates that are imaginary numbers in a sense. These are imaginary numbers. Okay, sorry about that. And the pattern is to look at the discriminant and then carefully substitute from your formula in standard form. There's your b, there's your a, and there's your c. And here we end up with a perfect square under the radical. So this will be two real and rational. Here under the radical we'll have a negative, so this will be two complex conjugates that are imaginary numbers. Again, this is not a perfect square, so you're going to get two real but irrational. And the same here. This is not a perfect square, so two real but irrational. I keep thinking, what is it like to use this tablet that I'm using to write on? It's sort of like signing your name on those little machines they have at the grocery checkout counter, where you really, don't get a good, well, anyway, my writing is a little better than this, but I guess you can get the idea. 13 is one rational because your discriminant becomes 0 here. And for number 14, two rational because, again, the discriminant's a perfect square. All right, well, let's go on. This is something different. Here they want us to write a quadratic equation having the given numbers as solutions. So, what technique would you do? Well, I would actually put this in factoring form. Again, there's different ways to do it. Now we know it's going to be opposite signs, so this is going to be a 5, and this is going to be a -6. And we have our x here. So what do? Well, we FOIL. So we get x squared. This is going to be a positive 5x, a negative 5x, so we're going to have a negative x minus 30 equals 0. So there is the quadratic equation in which these are answers. Again, I like this. We're working backwards, kind of developing closure. Now here's one where only 4 is a solution. Now remember, these are quadratic equations, so we need 2 solutions usually. But how about if the solutions are the same? And this is a little hint here. So it's going to be x, opposite sign, and it's that. So when we take the square root of this side and the square root of that side, we get x minus 4 equals 0, x equals 4. So now we have to expand this. I'll do it over here. Square the first term, multiply these 2 terms together and double it, and square this to get our c term, equal it to 0, so there's our quadratic equation in which 4 is the only solution. Now, this is going to be my hint for you. And then what do we do here? Well, again, it's opposite signs. So this will be a 2, and this will be a 10. And we just stick our x there. Now, this is going to be a -4. And watch this one now. This is going to be a positive 3. But what do we put here? Yes, 5x. So that when we transpose that, we're going to divide by 5. Opposite side. And what do we put here? Well, this is going to be, again, opposite sign, and this will be a plus. Now, this one's tricky, but it's going to be opposite sign. And do you notice what you have here? Conjugates. Okay, we'll let you FOIL and see what the original equation was like. I think this part is very interesting as we look more into the quadratic equation. Now, in these, we're just foiling. Straightforward. Just foiling. Again, for your final exam, you'll need to remember how to FOIL and later how to factor. Just foiling. But as we FOIL these conjugates here, watch what happens. We're going to get x squared minus, now the square root of 5 times the square root of negative The negative square root of 5 is the square root of negative 25, which just becomes a negative 5. Now, before, we would never be able to factor that, because that was not the difference of perfect squares. But now we get into the realm of radicals, we can. And keep in mind, this can be solved as x squared equals 5. So x equals plus or minus the square root of 5. So that would have been another way to do it if we weren't going to factor. Now, in a sense, we're using conjugates here. These would be complex conjugates, especially this one. So we'll give you a moment to work on this hint I've given you, and it's a skill you want to work on for mastery. So you can check your work. X's go there, and then now one is plus, one is minus, or actually it's opposite signs, but it doesn't make any difference. And the same applies here. And here, remember, these are in sort of a parenthesis already. So I probably should have used brackets there. And now you have to FOIL. Okay, as we do these, number 21 is pretty straightforward. And it fits into our factoring pattern very well. We're just going to FOIL, and they're conjugates. So this gives me x squared. And this gives me 3 times a negative 3 is a negative 9. And this is the square root of 100, which is 10. So negative 9 times 10 is negative 90 equals 0. That one's good. Now here we have x times x is x squared. Multiplying these, this gives us a negative 25i squared. But what is I squared? I squared is a negative 1. So this is going to equal x squared plus 25 equals 0. This is our... Now, getting back to number 23 was kind of bothering me a little. And I studied and studied and went online, actually, to look it up. And here it is. Again, we had set it up, perhaps correctly. Again, put these in parentheses. And these are your answers. So it's going to be opposite signs. That'll be a negative, and this will be a negative. So it's going to be x minus this, x minus this. Here are your conjugates in there, your complex conjugates. Now we're going to FOIL. And I've color-coded it, and we'll go slowly. So the first terms are our x's in black. So x times x is x squared. Now we're going to do our outers in the FOIL. So this is one, and this is the other. So we're using blue to code this. And keep in mind, there's a negative outside this. So it's going to be x, in a sense, a negative x times 3, which will give us a negative 3x. Then it's going to be a negative x times a negative 4i, which gives us a positive 4xi. Those are my outers. Now I'm going to do my inners. This one and this one. I'm coding it in red. Notice there's a negative there as well. So a negative x times 3. Negative 3x. A negative x times a positive 4i gives me a negative 4xi. Okay, I've done my first, my inners, and my outers. Now I need to do the last. And I'm coding the last up here in green. Now this is going to be a negative times a negative, so it's going to be a positive. I don't have to worry about signs. Now I have 3 times 3 gives me a 9. Now my inners cancel out because they're conjugates. So I have now a positive 4i times a negative 4i. That gives me a negative 16i squared. But we can't have an I squared. We have to convert it. So this is a negative 1 times a negative 16. This then becomes, now this is magic, watch this, a positive 16. So this here is going to become 25. Now notice what happens. This term and this term are going to cancel out. They subtract out. So we have here a negative 3x and a negative 3x. That adds up to a negative 6x. And we have our x squared. And that's our equation. That if we were to put it into the quadratic formula, we get these as answers. And that's the little supplement. 24 is a similar one. Now these are conjugates in a way, but they're not complex conjugates. I'll have to study that a little bit more. But let's go on to this one. Now we know this is a third degree equation having these three. So we'll set this one up. And in this one, again, we just put in opposite signs, FOIL these, and then multiply it by that, probably by long division, or long multiplication, I should say, and you get this. Now you could factor it probably by but it doesn't look like it's going to go that way, so let's just use this as our answer. And then here, again, since one of them is 0, we're just going to have an x out there. That's the one that's 0. We're going to FOIL this, and then multiply through by x, and that'll wrap this up. So again, a lot of stuff going on here, and deepening your knowledge of math.